Hello and welcome to AI and the Nature of Science, Concepts and Controversies. We are excited that you are here. My name is Alan Love. I'm the director of the Minnesota Center for Philosophy of Science and also a professor in the philosophy department here. I'm one of the organizers of this event. I have two co-organizers that I'd also like to acknowledge and introduce to you. Michael Cohen, adjunct professor of Homeland Security Technologies in the Technology Leadership Institute of the College of Science and Engineering. And then Galen Jones, director of the School of Statistics and also chair of the Data Science and AI Hub here at the U. And the sponsors for this event making it all possible include the Data Science and AI Hub, the Institute for Research and Statistics and its applications, as well as the Minnesota Center for Philosophy of Science. Now, as you saw coming in, we are video recording the event for posting to YouTube later. And also you can see that you have index cards that were put on your chair in advance. That is one way you can ask questions when we come to the general Q&A. There also will be a microphone that we will have to let people also ask questions verbally. I also would like to remind you that we will have a coffee break immediately after, and then at 4 p.m., Carl Bergstrom will be giving a keynote presentation entitled Large Language Models Disrupt Incentive Structures Underlying Scientific Research and Publication. And so it's all right here. Don't have to go anywhere. You're already in the right place. Now, I don't need to remind you that artificial intelligence is in the air and everywhere at the moment. It's reshaping the landscape of academics, business, politics, and especially the scientific enterprise. For the latter, there have been diverse and groundbreaking applications of large language models, which I'll just use the acronym LLMs, and machine learning methods in physics, chemistry, biology, medicine, cognitive science, psychology, and social science. These applications include both excitement and concern among scientists from different disciplines. For example, in a 2023 survey by Nature magazine, more than half of the responding scientists expected AI tools to be very important or essential, such as through providing faster ways to process data, speeding up computation, and saving both time and money, but also expressed concern that these tools could lead to more reliance on pattern recognition without understanding, entrench bias or discrimination in data, make fraud easier, and lead to irreproducible research. Earlier this year, a paper in the Proceedings of the National Academy of Science grappled with pros and cons. In How Should the Advancement of Large Language Models Affect the Practice of Science, the authors specifically wrestle with how LLMs can and should affect the practice of science, offering distinct perspectives ranging from seeing work with LLMs as not fundamentally different from working with human collaborators, to emphasizing that LLMs are often misused and overhyped, and that their limitations warrant a focus on more specialized, easily interpretable tools. In the article, a spotlight is put on the importance of transparent attribution and the responsible use of LLMs, as well as how crucial it is for humans to retain responsibility for determining the future direction of inquiry in different scientific disciplines. Within the space of this excitement and concern associated with these applications, there are additional conceptual questions surrounding AI and science. These include, how does scientific understanding connect with successful predictions from AI? What role do explanatory theories have when AI methods are applied to big data? Does AI inherently foster a prediction-oriented instrumentalist view of science in contrast to a more realist view focused on theoretical understanding? How should credit for discovery be attributed when AI plays a key role in scientific inquiry? Creating an opportunity to explore these and related conceptual questions motivated us to organize this symposium, especially in light of the relatively recently launched data science initiatives here at the University of Minnesota in both the College of Liberal Arts and the College of Science and Engineering, as well as the system-wide Data Science and AI Hub. The goal of the symposium and this panel specifically is to bring together cutting-edge perspectives on these questions and help set an agenda for future research and application. Our panelists are scholars who have explored issues of AI in the sciences and come from a variety of disciplinary backgrounds. Let me briefly introduce them to you. Cameron Buckner Professor Buckner is Donald F. Cronin Endowed Chair in the Humanities in the Department of Philosophy at the University of Florida. His research focuses on questions in philosophy of psychology and cognitive science, philosophy of mind and artificial intelligence, including mental content, cognition, and knowledge representation. In 2023, he published a monograph from Oxford University Press entitled From Deep Learning to Rational Machines: What the History of Philosophy Can Teach Us About the Future of Artificial Intelligence. Thomas Byrd, Dr. Byrd, is assistant professor in the Division of Hospital Medicine on the faculty of the Department of Medicine here at the University of Minnesota. His research focuses on developing and implementing AI-enabled early warning systems to predict and prevent in-hospital clinical deterioration, as well as embedding predictive models into clinical workflows using user-centered design and implementation science frameworks. Lisa Messeri. Professor Messeri is Associate Professor of Anthropology and Director of Graduate Studies in the Department of Anthropology at Yale University. She received a BS in Aerospace Engineering before turning to the anthropology of science and technology. She's the author of 2 monographs, including In the Land of the Unreal, Virtual and Other Realities in Los Angeles. Most recently, she has collaborated with cognitive scientist Molly Crockett to write a series of articles exploring the epistemic risks of AI in the sciences, and this work has been published in PNAS Nature and Trends in Cognitive Science. And last, but by no means least, Claudia Scarlata. Professor Scarlata is Distinguished McKnight University Professor of Physics and Director of the Minnesota Institute for Astrophysics here at the University of Minnesota. Her research focuses on galaxy formation and evolution using a range of complementary techniques. Her work targets galaxies at different cosmic epochs to directly trace their evolution while using local galaxies as laboratories to understand their distant analogs, with special attention to the role of AI in data gathering practices related to these inquiries. So let's begin our conversation with some overviews of work our panelists are doing that touch on the themes of the symposium. Claudia, let's start with your cosmology research. New telescopes are producing an overwhelming amount of survey data, and AI is playing a role in coping with it, enabling it to be turned into rapid, reliable science. Yet significant issues remain in the application of AI, such as uncertainty quantification or ensuring that results are physically sensible. Can you please tell us a little bit more about what's going on in your area?
Sure. Do I need this?
It should be on.
Can you hear me? Ooh. Okay. So first of all, I'm going to be the person probably most optimistic here. I was so optimistic that what I tried to do was to put the prompt that you just gave to ChatGPT and see what it came out with. It was actually pretty good. So I was positively impressed, but I had to touch on it, actually. So yes, I work on try to understand the formation and the evolution of galaxies as everyday work, and I use cosmological surveys. Cosmological surveys are basically observations of the entire sky that are being conducted with new telescopes. You may have heard about LSST or Roman. It's coming up, the James Webb Space Telescope. All of these telescopes are giving us a huge amount of data. Within the next decades, we will observe billions, tens of billions of galaxies. And what we are trying to answer with those data is very important questions about the universe, how it evolved, what is it made of, what is dark matter, dark energy, all of these things that we astronomers call them dark just because we don't understand them. Very well, I should say. So the point is that we are trying to make measurements which are very subtle, okay? And to understand and interpret these data, we need to perform simulations of the sky. We need to come up with artificial version of the sky so that we can test our pipelines, our selection effects, everything, so that we can answer the question or make sure that when we come out to you and say, we measure dark energy to 1% accuracy, we really trust that number, okay? So these simulations are very important. However, they require a huge amount of computing power. So our best Tools right now are what we call hydrodynamical simulations. These are numerical experiments that basically follow all the gas, all the matter, the black holes, the energy, everything inside the universe. They follow this with time, as a function of time, putting in all the physics that we know, gravity, the interaction with light, and all of that, and then produce all the galaxies, very good representation of the galaxies that we know today. So the problem with this is that there is a catch, of course. They're very expensive. It would be like trying and simulate all the waves in the oceans rather than only the tides, okay? So we can't just run this every other minute. So of course, you know where I'm going. There is not enough computing power out there to simulate the universe properly, also as a function of time. And these surveys give us data for the entire sky, which is really big. I don't know, have you all seen the images of these beautiful images from James Webb, the Hubble Ultra Deep Field? That thing is tiny in the sky. It's as large as my thumbnail here, really tiny. And so we are observing the full sky right now with that resolution, and we have to simulate it. So it's impossible to do it with these hydrodynamical simulations. So with my group, what we have been doing, we have been trying to use generative AI models to try and train models on these very high fidelity simulations so that we can try and reproduce galaxies much more quickly. And so we are doing that, trying to also constrain the generation process using physically motivated parameters. So when we ask AI to generate a galaxy, we don't ask to generate just any galaxy. We say we want a galaxy with this mass, with this rate of forming new stars, with this stellar age, some physically motivated parameters. So if you want an analogy, is if you ask ChatGPT to generate an image of a cat, you don't ask for any cat. You would just say, give me a cat with blue eyes that is sitting on a chair and there is the sun coming from the window. Okay, something very specific. So in this way, then, once the model is trained, we are able to create very quickly. This is the important part. We are now able to simulate very quickly many, many galaxies and use these simulations to test our pipelines and to make predictions for what the universe would have to look like. Of course, there are issues, and as you mentioned, one of the issues is how to make sure that the models that we produce are physically sounded, physics sounded, I should say. So we, in my group, one of the things we do that in 2 days, in 2 ways. I wish it was 2 days. The first thing, as I kind of mentioned already, we condition the generation part of the image on properties that we know are physical. So we ask the models to create galaxies within certain range of parameters that we know where they should be because we know what the universe looks like. There are physical laws that shouldn't be broken, so we know those. And so, again, going back to the example of the cat, what we are doing is not asking ChatGPT to create the image of a cat with 3 tails, 1 pink and 1 purple eye on the moon eating an ice cream. We are asking ChatGPT to create an image of a cat conditioned on very reality-based attributes so that the output we know is going to be physically grounded as much as possible. So that's one way of doing it. The other way is that once we have the so we treat these generative models as if they were standard cosmological tools, standard measurement tools that we would use in astronomy or in physics. And so we want to test the result. And so we take the output and we compare it with the distribution of properties that we know of for real galaxies. And we verify that things are working properly. If they don't, then we go back to ground zero. We change the training set. We change the conditions, for example, the parameters that we use or things like that. And sometimes we even have to change the architecture. So this is ongoing work, just to be completely open with you. So I don't know if we have the final answer, but that's the process that we are following. So these simulations are becoming extremely important in cosmological inference because these generative models are producing the simulated data that are used to interpret the real data. So if there is even a small bias in these simulations, they can change the conclusions that we draw from the real data. So it's really crucial that we understand that we can trust the generative model. So it's a little bit like when you're going to do you're out and you're doing a research project. And how do you make sure that the source that you're citing is a reputable source? So how can you make sure of that? How can we make sure that the product of AI is physically sound, is useful? So this is, I think, is where the frontier of AI, where the most interesting future of AI in my field is, to make sure that these generative models are, play the role of a physically grounded collaborator, someone that can help us, rather than something that is misleading the conclusion. And yes, I've talked about galaxies, cosmology, and so on, but I think any field that uses generative models faces the same challenges than astronomy.
Thank you. So let's turn from galaxies to people in medicine. So Tom, I know you've got a number of issues with your research that you could talk about, including treating AI as a tool for double-checking or expanding human work, the conflation of plausibility with validity in scientific inquiry that relies on AI, using AI to sort and filter high-quality scientific literature and resources speedily, and risks of superficiality and error when scientific methodology is automated. Can you share a little bit more about how some of these things crop up in your medical investigations?
Absolutely, and that is a lot of issues that do crop up and to talk about. And I'll just be practical in some examples here. My research goal is, as you mentioned, to predict and prevent in-hospital deterioration, and that happens when a patient's admitted to the hospital, but their course deviates from normal, what we would expect for their disease. So they suddenly and unexpectedly get worse, end up going to the ICU, much higher risk of mortality. So in this space for decades, people have been trying to make risk scores that stratify your probability of something bad happening, basically. And that's kind of been standard. They're really not very accurate, haven't been shown to really improve outcomes. And you can imagine why, because you're coming up with a probability of something bad happening. You don't really know what is happening. It could be they're bleeding out, their infection's getting worse, they're on the wrong antibiotics. So until now, we haven't really been able to have that prescriptive analytics piece. What's, I think, exciting with language models, and some groups have shown that this may work, is you have a predictive model that gives a probability of something bad happening. And then in this example, they're then taking the notes from a patient who is a high risk of something bad happening, having the language model look at the notes, and then trying to have it go through and pull out in human terms what might be going on and actually pull out perhaps a differential diagnosis. So you have something bad's going to happen and what might be the causes of that. Of course, this is something that in biomedical informatics people have been trying to have computers do forever, which is what's going on and what should I do about it. But I think with language models, we're close to that, which then brings up the issue of plausibility. You have a plausible prediction versus the validity. So I'm thinking about it in this setting. We have human written at the moment notes, and you're pulling directly from those. That can be your validation for the plausible prediction. You're validating it by what people think yesterday the diagnosis was, et cetera. I think the key additional technology onto language models the past few years has been retrieval augmented generation, or RAG, where the language model just looks at those notes, right? It's not pulling in the whole internet when it's telling you what the differential diagnosis for this patient. It knows those exact things, and you can link back to that piece of the note that it's thinking about. That's, I think, a very powerful concept in modern day AI, and then goes back to the concept of summarizing all this literature and things. Again, I'll use the medical example because I'm familiar with that, but there's an app that over 40% of physicians, as of a few months ago, use called Open Evidence, which is a language model that uses RAG, and the database that it searches from is all high-quality medical records, medical journals, articles like the New England Journal. And it's just like a ChatGPT interface. You can ask it what's the differential diagnosis, what's the treatment, and it'll tell you, and it'll link back to those specific papers or FDA monographs. So that's pulling in the validity there. And it's a $4 billion company, and it's only been around for like 2 years. So people are using it, which brings us to another issue or concern. We have a tool that works so well, now we're at risk of automation bias, or even with the medical school and training, not learning the skills that we need to do these things by ourselves. And some of our educational leaders have been bringing this up and seeing residents who if a patient they're following has a new symptom, they put it in Open Evidence and then copy and paste it into their note. And so it's very easy to offload a lot of these cognitive processes to AI, but what does that do for us if we need to actually use those processes ourselves without ChatGPT in our pocket in the future? So finally, I think this, we can talk more about what we do about all this, and I appreciate, the domain we're talking about is scientific research in general, but for one more specific example in medicine, radiologists have been interfacing with AI, I think the most of any specialty. And according to my colleague at Mayo, they tried, the initial thought was, radiologist reads a chest x-ray, the AI at the same time puts little boxes around where it thinks something bad's happening. And they found that radiologists were just relying on those boxes and missing other stuff. Could have seen that coming. So what they do now is they have the radiologist read the chest x-ray like normal, unassisted, and then the order operations, the AI then puts those boxes and sees if the radiologist missed anything. So I think that's one way that we can make these kind of risks, these cognitive risks of losing and de-skilling less if we do that order of operations. Still could be an issue if you're just, the AI is going to check your work. You probably aren't going to work as hard that first step, but I think it's something that we can kind of think about in the broader research field, conducting studies, designing experiments, try to design the experiment yourself first and then see what ChatGPT has to say about it. Stop there.
So that's both encouraging and I think also cautionary. And maybe some people in the audience are a little nervous after Tom's comments, but maybe we can come back to that in open Q&A. Let's turn from medicine to the mind. Cameron, I know you've got a number of things in this space. One is how to interpret computational models that are designed to predict and simulate human behavior, such as whether their trajectories of improvement with respect to predictive accuracy are appropriate or whether they might help us develop better explanatory models of human cognition. Another might be labeled scientific progress with opaque methods, such as AlphaFold's protein folding predictions being based on features that are too complex for humans to ever really understand. Should we trust them?
Okay, thank you. Yeah, so as a philosopher of science, as Alan mentioned, I like to look at different models and use them as case studies to try to see what is the vision that AI is giving us for science in the future. And two models that are useful as case studies here are a model called Centaur, that is a fine-tuned version of the large language model Llama that was fine-tuned on over 160 different experiments, tens of thousands of data points from different subjects to better simulate human data in behavioral experiments. And then AlphaFold, which is better than every other method we've had up until now at predicting the course of protein folds. And I'll talk about philosophical issues raised by each in turn. So we recently wrote a commentary on the Centaur project. And the people who created this model, they offer it as a very important step in coming up with for the first time in history, a general explanatory model for human cognition, right? And as evidence for that, they show that this model can do a better job than anything else we've had so far at predicting human behavioral responses to all of these different behavioral experiments, okay? So as philosophers of science, we say, okay, well, does merely the ability to better predict subject responses than anything we've had so far mean that we now have an important step towards having a better explanatory model. In philosophy of science, we have a distinction between phenomenological models of some phenomenon, which is sort of the shape of the phenomenon to be explained. In this case, it would be input-output profiles. What is the input the subject in the experiment is receiving, and what is the behavioral output they put as a result? And on the other hand, process models, which are supposed to tell you how they transform the input into the output. And you might think you really need a process model to explain it, and there's really not that much evidence to think that Centaur is going to be a good process model for the behavioral responses that people are giving that give them explanations. There's some sort of generic reasons to think you could buy arbitrarily better degrees of fit to behavioral data in experiments just by further fine-tuning a model as much as you want, as much computation as you want to put towards it, because these models are trained by gradient descent, and you can show there's general principles of machine learning that they're always just going to get better and better at fitting whatever function curve you give them, right? But there's other optimizing methods out there too. So Bayesian methods, for example, are also going to do some kind of pseudo-optimal calculation of the right output to put in response to different input, but they use very different processes to perform that input-output transformation, right? So the fact that we have a model that can produce the same input-output doesn't necessarily mean we have the explanation for the way that we do it, and there could be others. The human could be at a third optimizing process for doing that. So that's a general worry about, what have we really learned by using this model. Now to move to AlphaFold, a very different approach or way of using AI in science, right? So as many of you probably know, AlphaFold did better than any human analytical models at predicting protein folds on its first try, and then AlphaFold 2 basically solved the whole test set, which we would have, most of the protein folding scientists would have thought is completely impossible until it was actually done. I think scrutinizing the details of how AlphaFold is actually quite a different architecture than AlphaFold 1 that in part explains its better performance is really important here. So in particular, they changed the architecture in ways that were guided by specific constraints that they'd taken from those analytical protein folding models. So for example, they built a proprietary form of self-attention in transformers called triangle self-attention that honors kind of three-dimensional constraints in the ways that proteins can fold to kind of rule out a whole bunch of implausible possibilities and focus on the ones that are particularly likely to lead to a good solution. Still, and this raises a really intriguing possibility for what this means for scientific understanding, the model remains extremely complex, and it might be predicting protein folds so successfully on the basis of features which are like real and predictively valid, but they're so complex they're like beyond human cognitive understanding. We can never really like grok what the feature is that it's latched onto. In some of my published work, I've raised, there's a particular worry of this, namely that we might be discovering artifacts. So an artifact like a Doppler echo is something that has real predictively valid information that it will generalize to new situations. But it can also be misleading if you don't know what the cause of the artifact is. So like when we learn how Doppler effects work, we can have Doppler radar. But if you don't, you're going to be led to a bunch of incorrect inferences. So what does this mean for the way that AlphaFold 2 or AlphaFold 3 or 4's predictions could be used for science? Well, suppose as a result of one of its predictions, we identify a new target for a drug intervention, right? That could be huge for health and medicine and protein folding science, but we don't know whether it's an artifact or not because we don't know, we don't understand it. We can't really sort of check it ourselves. I would suggest the problem here is just kind of a way to figure out how to plug this into workflows of epistemic practices that we already use for human-generated science, right? And I think leaning too hard on human understanding could be a little bit misleading here, right? Because we already have all of these drugs that are FDA approved and really essential, and we don't know what the mechanism of action is, right? What we have are a bunch of epistemic social practices that are super important, right? We have like phase safety trials, we have double-blind controlled efficacy experiments, and so we would just plug that into the appropriate place in the existing epistemic practices that we've developed through doing things the wrong way a lot in the past, right? So these give two different visions for the way science should progress. So I'll end with sort of two general morals. So one moral is that I think a difference between Centaur and AlphaFold 2 is whether or not we have sort of empirical links between the internal structure of the model and structural features of the systems that are generating the phenomena that we think we need to explain. And there's a burgeoning area of computer science called mechanistic interpretability, where you actually study the internal causal organization of these models, and you can use the best methods from philosophy of science, causal interventionist methods, to try to verify that you've got a good causal understanding of how the model's organized. And then the more structural links you can draw between the system you're understanding and the model, the more faith you might have that its results are real and going to generalize in a useful way. Also on the topic of understanding, we should note that issues of how important human understanding is have already showed up all over. This is sort of the old Einstein versus Bohr debate about how important is the sense of familiarity or illumination for the human versus just getting the empirical details right. And I think philosophy of science has a lot to say about that. For what it's worth, I'm a fan of these kind of ability to answer a whole bunch of what if things have been different questions. And we can think of different ways that might work, even if in some sense the features the model's using are opaque to us or unavailable to us. But we can still show that we can answer a whole bunch of what if things have been different questions that are relevant to our inquiry.
Great, thanks. Now, I've saved Lisa's opening remarks for last, in part because in correspondence, she's a self-described AI skeptic. And one of your concerns is epistemic risks, such as illusions of understanding and problems arising from the use of AI surrogates for humans that promise faster and cheaper pipelines for human subjects research. You think these applications say a lot more about deficiencies of the fields in view rather than the potential of AI. Can you say a little bit more about that?
Thank you. And it's, I don't know, happy to be at the end of these comments with the optimism and the hope, even with cautions. But maybe for some of you who are sitting nervously in the room, this will be food for thought. So the work that I've been doing on AI and science has been, as was mentioned in the intro, with my collaborator, Molly Crockett, who themselves is a cognitive scientist and has used machine learning in their lab for much of their career. And I, however, by training, am an anthropologist of science and technology, meaning I am used to thinking about the large scale and the social context in which scientific and technological innovations occur, whereas Molly is the person who's down in the lab doing the work that I, as the anthropologist, observe from a comfortable distance. But it has been an incredibly productive conversation to really figure out how the social sciences, the humanistic social sciences like anthropology, and the quantitative sciences, as Molly practices, really need to be in conversation when it comes to questions about AI and science. And that's in part because when we are thinking about how AI impacts science, it's essential to ask it at the discipline level. What can it do for astronomy versus medicine? But also at the kind of social level, the way that a philosopher can pose a question or an anthropologist can pose a question, really understanding how scientific work sits within a larger epistemic community. And also, I would add, a larger political economy situation where you have forces like for-profit companies such as OpenAI offering tools for us in our university labs. Maybe I'll come back to that in the Q&A, but I just wanted to flag that part here, and also, again, why it's necessary for this to be a multidisciplinary conversation. So the work that we've been doing, there's two parts of this research I'm going to touch on in these opening remarks. The first one comes from a paper we published in Nature in 2024 titled Illusions of Understanding, Artificial Intelligence and Science. I kind of forget what it's called, but Illusions of Understanding being the operative term. Now, the quest we had with this paper was to get out of asking or pointing out the problems of hallucinations or even biases in the data sets, et cetera, kind of the well worked out epistemic risks. We instead posed, let's presume AI systems work exactly as intended. Let's say they do deliver us to the mecca of scientific work. Do risks remain? Should we have entered the promised land? And our focus then became on what might the world of scientific work look like if AI have truly become our collaborators in many different domains of science. And in order to allow us to think about what that future looks like, we offered a bunch of different languages and frameworks to communities and people interested in thinking about this problem. The first thing we did was to break down AI from kind of the monolith into really looking at across the research pipeline where are visions for AI being articulated. And that exists at what we call kind of an AI oracle, kind of at the lit review stage, right? Where you're just kind of like looking for what's been written or even just questions to be asked. And remember, this is assuming that all the hallucination stuff worked out. So it's giving us, good information or good citations. Then there's also the AI surrogate, kind of the image of the centaur is a good one to return to, or the Centaur paper is a really good one that I'll return to, where AI is being imagined as a proxy for human subjects or any kind of experimental data set. You then get AI quant, which is more about how do you use AI to deal with these large kind of data sets that we have, either with AlphaFold or with cosmology. And then AI as arbiter, some of the stuff you've seen with like AI and peer review, for example. So we have this sense that there's all these imaginations for AI intervention on the pipeline, all of which leads to this vision of the fully automated AI scientist. This is well articulated in a technology review op-ed written by Eric Schmidt, one of the founders of co-founders of Google, or former CEO of Google, who himself is now very much leveraged in AI and AI products. And he envisioned the AI scientist where the PI would leave the lab, and in his absence, the AI scientist would generate a hypothesis, run some preliminary, order the things you need for an experiment, run a preliminary experiment, create a draft of a paper, all while the PI is home asleep. So he comes in the next day and he can see what the AI scientist has been up to. Now, this was seen as kind of this, tremendous vision for where we might be headed, but it really raises a series of questions about the plausibility of there ever actually being a PI who then could know enough in order to oversee this kind of AI worker in its stead. So to get to the point of epistemic risks, we asked what vulnerabilities do we open ourselves up to when entering into a scientific collaboration with AI products? And we noted that in so many of these visions, these AI products are anthropomorphized. They're talked about as collaborators, as researchers, as students, as trainees. And when we begin, and we don't do that with an fMRI machine, for example, right? If we do it, it might be very teasing, but we would talk about it as a tool, as opposed to a collaborator. When we allow AI models to be, or LLMs to be our collaborators, we have allowed them to come into our communities of knowledge. In the kind of cognitive science and psychology literature on communities of knowledge, which happen in any kind of scientific collaboration, we know that in entering into a community of knowledge, we open ourselves up to epistemic risks. We open ourselves up to losing track of what we understand as opposed to what someone in our community understands. And in the literature, this is known, one mode of an illusion of understanding is an illusion of explanatory depth. Meaning, if I am in a collaborative team and my collaborator knows a lot about dark matter, but I know very little about dark matter, I might think I know more about dark matter than I do because I have a trusted companion in my work who does understand this field well. With AI, you have a tool that we're being told knows everything by some of its boosters. And so you risk having an incredibly dominant collaborator in your community of knowledge for whom your illusion of explanatory depth can really be heightened. Another, riffing off of that kind of established illusion, which has been empirically supported, another illusion that we think that AI products, when we invite them into our communities of knowledge within the sciences, make us vulnerable toward is an illusion of explanatory or exploratory breadth, which is in moments when we are being deeply incentivized to be productive, to be incredibly efficient with lower resources. And then we were also given a tool which promises us to save money and work faster. We are being more and more incentivized into using this tool. We therefore create projects that might be well suited for the use of this tool. And that happens with this happens all the time, right? This happens with every scientific tool that enters it. We do a lot of analogy building, Molly and I, thinking about fMRIs and how that really changed neuroscience for quite some time. The risk here is that you don't see that you're undergoing this epistemic narrowing. And again, because of the anthropomorphization of these AI products, particularly, again, the large language models, there is a risk here of not understanding that we are kind of succumbing to this, that there is an illusion of explanatory breadth, or exploratory breadth, where we think we are surveying the whole domain of possible science questions, but we're really being incentivized to only survey the domain for which these tools are particularly good at helping us. So what all of these, and we write about a couple other illusions in the paper, but what these lead to in Molly and my analysis is the potential of the emergence of scientific monocultures, where instead of investing in supporting a broad range of science and research, we over-leverage on a much narrower, section of the largest field of scientific work that we might be doing, which then creates major vulnerabilities in what a healthy scientific institution looks like. So again, the purpose of this analysis was to give the benefit of the doubt to these AI products and say, let's say they do work as well as we're told that they might down the line. What does that mean for science? Well, it really opens us up for risking to cultivate monocultures as opposed to kind of the beautiful array of research questions and ideas and methods that we aspire to push ourselves toward and train our students in. And we see evidence of the monocultures emerging as we hear about 100 faculty in AI being hired at University X or University Y. Sorry, that was quite loud. Just to kind of put one other idea on the table before we open it up to broader conversation, because you brought up Centaur, that has been also a provocative thing that Molly and I have been thinking about as well, this promise of a kind of an AI surrogate for the human sciences. And in fact, when we began this collaboration, we started thinking we were only going to write about kind of AI surrogate. And we the Nature paper was actually a side quest in which we're like, okay, I guess we can say something about broader epistemic risks in science. But we returned to our side quest recently, or our main quest recently, under a project that we had always called A Human Sciences Without the Human, really asking what it could look like should these kind of AI surrogates become dominant in particularly psychology and cognitive science research. And I really like what Cameron said about his approach as a philosopher to this, because part of what Cameron instructed us toward is that something that actually is very generative about these generative models is that they allow us to ask questions about the epistemic kind of communities and practices that see these models as desirable. So for the specific example of the AI surrogate, and this is work that we just published a couple weeks ago in Trends in Cognitive Science, we kind of noted that something like the Centaur model only becomes thinkable, the excitement that someone who does human subjects research to be then given an AI and say, look, it's a human subject, that is only possible to have excitement about that given the previous 15, 20, 30 years of how the development of cognitive science has proceeded, such that it has moved further and further away from kind of undergraduates coming into a laboratory, doing experiments and leaving, to experiments being conducted online, to experiments being conducted with survey tools and experimental tools like mTurk online, such that when you get kind of an AI model that operates a lot like MTurk, you all of a sudden think that you have the next kind of step and paradigm in cognitive science without realizing that what has happened is an epistemic narrowing. So there is actually another really exciting use of these AI tools, especially for an AI skeptic, which is when one sees and when one encounters enthusiasm for AI in a particular vein of science, it can actually be a helpful heuristic for perhaps pointing out historical trends that have torqued or narrowed a scientific field such that a tool that might actually be counterproductive or counterintuitively enthusiastic, raising counterintuitive enthusiasm could actually tell us something about a deeper seated shifts in the paradigm that have occurred over time that might actually be due for a corrective. So I will stop my comments there.
Okay, thank you. So lots of stuff on the table. Before we turn to sort of open Q&A, I want to ask a couple questions maybe that panelists can weigh in on if they would like to. And this one follows on Lisa's comment about the way in which the culture of science could change. To what degree do you think AI has an impact on the training and development of the next generation of scientists? I mean, Tom also mentioned that they're seeing these interesting potential effects on the next generation of doctors who are sort of more digitally literate in the sense of being comfortable using the tools. So I wonder if anybody would like to sort of share any comments on that.
I'll speak to that at least. I think there's an interesting distinction. It's those who are using the AI tools in their training, like the example I gave. And then there's those who are trying to do research, and now more and more frequently about AI. I don't know if it's the same in your fields, but over the past 3 years, there's just been an explosion of papers that said ChatGPT can pass the USMLE, it can do this, it can talk to patients, and give them advice, just people prompting the ChatGPT to say something. And yeah, that's interesting, but then the model changes a few months later and it's essentially obsolete. And I worry about those, medical students or undergrads, anyone who's interested in research and kind of gets trapped in this funnel of doing something that's not really making their future research abilities stronger. It's interesting, but I think it's a bit superficial. So I do worry about that.
Others?
Yeah, so I do think that AI should be a big part of training people for a wide variety of different scientific fields, but then there's two very different ways that can go, depending on especially how it's being offered or pushed by administrative policies, right? So one model is you tell all the students, oh, you're going to be expected to use AI to be more productive when you get a job. So we're going to give every student access to some AI assistant. We've got this big contract. And then we teach them to do it in their classes. We teach them to use it to write papers. We teach them to use it to critique each other's work. We teach them to yada, yada, do experiments and everything, right? I worry a lot about that model, in particular because of de-skilling, right? So whatever skills you're really interested in, if you think that AI is not perfect at doing those things already, then your ability to know when it's doing something wrong depends on your understanding it independently and being able to critically evaluate it. So I teach an AI course every semester as part of my job, and I have the students engage a great deal with the AI tools. But for me, it's all to teach critical engagement with the tools. So I do a bunch of group projects where they're supposed to get the AIs to make mistakes, use the AIs to do things, but then also elicit the failure modes and get them to critically understand what the things are good at, but especially what the things are bad at, so that they don't lose the skills that they would need, and they also have a better understanding of the AI that they will, let's be realistic, be expected to interact with a lot when they leave the university.
Yeah, I just want to underscore the first point you made there, which is, and which Tom made as well, which is on the de-skilling. I mean, I offered the Eric Schmidt vision of the AI scientist because that scientist can only be a good minder of the products if they have gone through more or less traditional training to be a scientist. And these visions are often put forth imagining this current state of scientific knowledge that we all contain in our minds right now, and the training that we've had. And if this is like the group using these products, it seems like there's some good futures out there. But I don't think there is a way you get this group with the kind of the de-skilling that is inherent in using these products. So there's just a fundamental flaw of this image, which is failing to look 10 years in the future. And the other point I would just add is, there are some examples, like what Tom brought up about open evidence and some more like tailored products very specifically for scientific work. But so much of these are either being fine-tuned on or trained on or back-ended with ChatGPT, Anthropic, Gemini, which are models put out and maintained by for-profit companies who have not professed any interest in science other than to the extent that it is that universities are a revenue source. And we don't know, they have no incentive to maintain these tools for us to use in the future. And this should be incredibly worrisome, especially if they're ingrained in our training pipeline, because there's no guarantee that they won't just like pull the plug or say, okay, now give us $1,000 a month if you want to keep using this model. And there are open model products, and I do think that if there is a future here, we need to be much more thoughtful in investing in those infrastructures as opposed to partners with these companies.
Perhaps following up on that, it reminds me not too long ago in the past when companies were pushing for training our students into becoming programmers. Everyone wanted to go into computer science to learn Python or whatever language that you want. And now it's not that anymore, so suddenly that changed very quickly. So how are we not going to repeat the same mistake with AI? I think it's related to what you were saying. On the other hand, as I said, I'm probably the optimistic one here, and I see AI as a tool, like you said earlier, and like the calculator. When the calculator was invented, the risk is that then we are not, the risk at the beginning probably where people say, oh, people won't be able to do multiplications anymore and divisions. And it's just, I think it's just in our duties as educators to find the best way to teach how to use the tool, to make sure that the critical thinking is there in the student. And I don't have a solution yet, absolutely, but
yeah.
I think...
No, I always like the calculator analogy because I think it's spot on. And it's notable that we still insist that students in their primary education aren't given calculator until they develop an intuition for math and numbers. And so much of what we're talking about on this panel is critical thinking. And no offense to any undergraduate who might have snuck into this room, but the undergrads who come to me don't know how to critically think yet. And so I fear giving them a tool that replaces critical thinking until they've really sat. I don't know if I know how to critical think yet, right? That comes so late in our training. Yeah.
So let me ask one more big open-ended question, and then we'll transition to audience questions. And it's a combination of a very practical question, but also one that gets at what the nature of science is. So the practical part of the question is, when AI is involved, how is credit assigned? How do we think about the distribution of credit, whether that comes in the form of authorship, or in the form of awards and acknowledgments of discovery. And that is why this, I think, moves also into the space of the very nature of science, because we oftentimes associate the big breakthroughs in theoretical understanding as more than, say, predictive accuracy, more than getting things a little bit more precise than they were in the past. And oftentimes we give awards like Nobel Prizes for those sorts of achievements because we think they represent a kind of pinnacle of human creativity. So I'd like to invite the panelists to say something about how they're thinking about credit in the sort of use of AI in science, and maybe what that might say or not say about our broader picture of what science is.
I can take a stab. I actually think it's sometimes easier to think about in the case of AI-generated artworks or potential artworks, and I teach this in my class sometimes, where what you might think about, a generative tool is like a choose-your-own-adventure type book, or one of these interactive videos on Netflix, right, where you do credit the creators for making the thing, right? You don't credit the person who chooses which pages to flip to, or the person who chooses which things to click on in the Netflix show. And I think, when it comes to something like AlphaFold, I think maybe it does make sense that if you are creating a bunch of downstream effects with that tool, that the people who made that possible by creating the generative space that allows you to get all of those useful outputs should be the ones that get the credit. When it comes to like crediting an AI as a collaborator, I'm not sure there's anything there that's really proper topic of credit, in the same way there's not really a way to treat them a proper topic of blame if there's a big mistake made, right? So I don't think we have any agents that are sufficiently sophisticated where it makes sense to credit an AI agent itself. Maybe people have this.
Yeah, I agree. I think the whole point of credit is a human nature one, either to receive recognition, to publicize that, to show what you've done. I mean, obviously the AI doesn't have any skin in the game, and it's useful to know what's AI generated and not. I'm maybe biased thinking of like the writing a paper space. Do you give AI credit? And from the beginning, people have been pretty clear that, no, you don't give AI credit. You can credit the tool like you would credit ChatGPT or Grammarly. And so putting it in that context doesn't seem like such a profound decision, right? Until you have the PI of the lab who is AI, then they can write their own credit,
But what about crediting the sources that have been used to train the models then? That's very important. So how do we do that? I think I've read it somewhere on, maybe it was an Economist article, I don't remember, but a model in which ChatGPT or these generative models pay standard flat fees to various websites that have been used to gather data for the training. So that's one model of attributing credit, just paying.
Mm-hmm. Yeah. Do you have any thoughts, Lisa?
So I think a lot of this is going to be more the stuff that we think should go in a methods section, right? For evaluating what was done and understanding what the risks might be and where, if you wanted to reproduce it, you might go to look. So I think that's where a lot of the credit issues should go. And it's up to journals, too, to adopt principles for like whether they're even going to allow AI-generated assignments.
So let me push everybody to the second part of the question, just to sort of see if you have any thoughts on that. Is it the case that the nature of science changes under AI, or is it more a matter of scientific enterprise just appropriately assimilating AI in some way?
I'm optimistic, but the narrowing of science that you were talking about is worrying. It's something I had not really thought about before. It seems to me that's a point that funding agencies should keep in mind, because it's in the benefit of science more broadly to make sure that we do not go in the narrow direction. And so a different funding models for science would probably be a way out of that.
The nature of science. I think there's a warning for us all also at this moment, which is we're not living through a moment when a lot of people want to give us money or trust as a university. And if we cede too much ground to these AI products, does that weaken our position when it comes to the necessity that I think we all believe the university has for society? If there can be a narrative about most science is done with AI, where does the scientist and where does the university fall within that world? So there is also kind of a strategic defensive posture that we can take that would be very cautious about how we talk about the way AI is quote unquote changing science when we are talking with broader publics.
Any other thoughts on the nature of science changing or not changing? Medicine forever different, Tom?
I think if you go into medicine now, be prepared for the field to change a lot in the next 5 years. But I think it's always been changing. When I started, the electronic health record had just begun, and people were lamenting that. And we've figured it out. I think the key is having the right motivations in the right place. And perhaps similarly, I do worry that big tech is going to be driving the changes in medicine, which will have downstream effects on research and the nature of science. So yeah, perhaps fundamentally the nature of science and as a thing that you pursue will not change, but how and why could very well change.
Actually, maybe just add one more thing to that. How do you get people excited to become scientists? Like, how does within this world we preserve that genuine sense of curiosity? As opposed to just presenting science as being an AI minder. That's not where we're at, nor I'm saying where any of these projects necessarily lead us to. But this is part of, a lot of people who aren't scientists and imagine the role that AI might play in science say, like, wouldn't it be great if AI could run your experiments or write your papers or this or that? And I would go, I love running my experiments and writing my papers. Like, why are you trying to take that away from me? And so I do think there's another kind of posture to take, which is let's not let efficiency be the primary driver of how we make decisions about our practices going forward. And what does it mean to really stand up for science as a human endeavor when driven by creativity and passion? And note that even if that might be less efficient or more subjective than the ideal view from nowhere, that is what we're fighting for and what's worth preserving.
Okay, well, I think that's a good point of transition. So Anna and Keely will be coming around with the microphone, or if you have an index card, you can pass it to the middle and they will come by and pick that up and then hand it off to me. But please now, this is an opportunity for everyone here, as much as time allows, to ask questions. So please raise your hand and I will call on you and we'll get started. So let's start right here in the front. Anna? Yeah. Okay. We'll go to you next.
Oh, sorry.
It's all right. Go ahead.
Hi. Thank you all so much. This has been really illuminating and helpful. I wanted to ask your thoughts on pursuit-worthiness as a property of scientific hypotheses in the context of AI, and specifically related to thinking about things like protein folding and how we've sort of assimilated the pursuit-worthiness of particular hypotheses about protein folding to probabilistic prediction, right? To pattern recognition. I'm thinking about this in the context of like Marshall and Warren's pursuit of the bacterial hypothesis for peptic ulcers that like eventually won them the Nobel Prize over the acid hypothesis. And like that, in that moment, that hypothesis is deeply disfavored by the scientific community. Almost nobody is pursuing it. It looks bonkers for them to bother. And yet they do. And it's not clear that in the context of, or at least not clear to me, in the context of using AI to probe the space of hypotheses and choose pursuit-worthy hypotheses, if we have a series of models that are trained on past choices by researchers, that we're going to end up with a lot of pursuit-worthiness weight, a lot of pursuit-worthiness reasons showing up for cases like these, where like the pursuit-worthiness has to do with things like how many people are actually pursuing it, how willing are you to go out on a limb and look like an idiot. So yeah, I'm curious about your thoughts about pursuit-worthiness in this sort of scientific paradigm.
I guess I'll say something if nobody else is wanting to start. I think there is a common narrative that philosophers in particular need to combat when it shows up. So a lot of times that the AI scientific workflow is sold to people that try to pitch you as being a value-free alternative. So they'll often point to all of the human biases in the history of hypothesis choice and the way data are crunched and stuff and say like, well, let's just turn it all over to the algorithm. But I think the point that you just raised, and the one that philosophers really need to hammer home, is that there is no value-free science, right? Anytime you train these models on some data, there's values that are kind of inherent in the data set that you use. There's values inherent in the architecture choices that you make. So there is no value-free alternative. So this is not to say that using AI in science is always bad, but that there always needs to be this reflection on what value choices you're making by picking a certain data set, picking a certain architecture. And in some cases, these are empirical questions that need to be pursued independently of whatever you're trying to get out of the model.
And just to add, I mean, I think especially when it comes to just LLMs, I mean, they produce a normative response. That's what they're designed to do. So I think your intuition there about the extent to which these tools can help one think orthogonally or in a heterodox mode is a good intuition to have about the use of these.
Okay, next.
Hi, thank you. So I'm going to ask this question from the perspective of someone who lives in a body that will do its inevitable thing, which is to die, and probably through that process at some point have a number of experiences that lead to what ultimately happens to us all. And at some point, we'll probably interact then as a patient with a medical system. And so, Lisa, you said something that I think is very important, which is about, the ownership and the impulse to, create and sell these things does not originate necessarily from a scientific intent, being that it wants to say real things about the world, but originates from a business intent or has ended up a lot of it in that way. And then, Tom, you mentioned that, a lot of research interest in healthcare is around how can we use these technologies to sort of deal with data better and learn things. And while that's happening with things like, hoovering up the language to try to find signals in the healthcare system to help it do the work better, while that's happening, there's still this very rapidly adopted technology of ambient listening that feeds the health record with synthetically extruded text. So suddenly then, and I think, Adam Rodman has written, kind of pointing this out, that you get the inputs are synthetic, devoicing patients and devoicing physicians, and sort of taking all that natural language and making it artificial language, I suppose, and then feeding that back into a system of discovery. What kind of conversations are you having, or are there to be had, about this kind of, circular sense of discovery about human experience interacting with a widely regarded, not perfectly functional American health system?
Wow, great question. I think it touches on so many things that I think about, and to the idea that's been around for some time where you have AI output and it's kind of being fed forward. Specifically in the EHR, this is very valid because, the scribes, the whole point is that you pretty much take what's there and feed it in, and there's concerns about losing kind of the human touch or small details, your pet's name, that's kind of just whitewashed. But moving forward, how do we use that information for prediction? Like my example, do we use that to predict deterioration in the hospital if all the notes are just kind of boilerplate, or not bringing that human critical thinking into the EHR, or they may be useless. So I don't have an answer, but I think it's something that may change a lot of things. There is a predictive model that looks at nurses' notes and uses that, and it performs quite well. These are human notes, though. So I imagine that will change as more of the notes become AI.
Can I clarify? Because I think that model, it's not necessarily what's in the nurse's notes, it's the observation that the nurses are more frequently going to the patient's room.
The concern model?
It's the note is an artifact of human behavior that their model picked up. We're thinking about this.
Yes. I've seen a couple flavors, but right. The presence of that worry. In the predictive model space too, you predict something in the hospital, And in theory, that changes the outcome. And then you look and see how the model's performing later, and that changes as well. So there's all these colliders in the real world in complex systems that are just so hard to disentangle. And maybe for better or worse, healthcare is so complicated that I think it's going to be really hard for AI to come in and kind of just ruin everything really quick, as much as it might want to. Like, so I think we have some time, but at the same time, the frequency with which and the speed that ambient scribes have come into healthcare has been super fast compared to how things usually change in medicine. Our division director says it all the time. He's like, in my 30 years, nothing's moved this fast. So a little bit of get up and go for us to kind of figure out how to do it the right way. Yeah.
Okay. In the back. Yep.
Thank you. Fascinating discussion. Science has been described as practices we've developed over the centuries to help us make sure we're not fooling ourselves. And it was brought up by the panel that there are epistemic checks to science that exist. But those epistemic checks were designed under a human-generating system. And so, and I've been thinking about this because we see this, for example, in all our classes, where for many years we developed essay writing as a way of determining if there was knowledge in the student. And I don't really care. I mean, I do care if the student can write an essay. That's a different question. But one of the purposes of the essay was to detect knowledge in the student. And unfortunately, grammatically well-constructed essay is no longer a valid judge of whether student has knowledge. I can read an AI-generated essay and usually tell that it's not the student's, but it takes a much more effort. The old epistemic checks that I had don't match that anymore. So my question is, particularly for the panel who's been thinking about this, are there new epistemic checks that we need to put into our scientific practice beyond peer review and data sharing? And Alan knows the whole issue. We've both spoken on this extensively. We have several publications. The complex story of the reproducibility issue, which is far more complex. I won't get into it. But things like triangulation. I mean, there's all these processes that we've developed as in the scientific community that I'm not sure will catch AI issues. Are there new epistemic checks that we need to put in, and what might those be?
I think this is probably the topic that I hate most about, not your question, but this conundrum that I hate most about this moment, which is, yeah, the essay was really good for testing something, and then, this tool comes in and smashes it. And why is it now it's our problem to find something new? So I completely agree. And part of my taciturness about all of this has been to be like, no, I don't have to change this. This works, right? And so there is I think that's a fascinating question about the epistemic checks and signs, which I'd have to think a little bit more about. But I want to just go back to the premise that we need new checks as opposed to wanting to fortify the robustness of our social systems that say that this is not acceptable, right? I mean, that's what I try to do in the culture of the classroom that I'm working in. And it's not working because it needs to be the culture of the university. It needs to be the culture of kind of our learning institutions. But I don't think we should give up the fight too soon because there have always been ways to cheat on essays. The problem is that this is not yet stigmatized as cheating. It's starting to, but we were behind the ball on that.
I don't have an answer. Let's start there. But it seems to me that the solution goes in the exact opposite direction from where AI was invented. So AI came and or perhaps is used. It's used to make everybody more efficient, faster, more productive. We have said that. And to me, the solution seems to be slow down the review process, make it more thorough, do an oral examination with the students rather than a written exam, and that scares the student in a way that, but in fact, it's the only way to really check if the student has understood. Do we want to do oral exams every time a person puts out a paper? Probably not, but I think, really it's to make the process of reviewing more thorough, just slower then. So I don't know what the solution is.
And then to insist that our promotion committees and our job market also responds to that necessity, right? So it's all at the same time.
Okay, next, Yaniv here. Yeah, microphone's coming. Why don't you use that? Thank you.
So thanks, super fun, lots of ideas. What was I going to say? So first, answers to your questions. Right, AI is not a collaborator, it's a tool. I'm in the field of evolutionary genetics, and new tools have arisen, sequencing, et cetera, and when those new tools arrive, there people who use them kind of for any use or who are brave to use them or use them in new and exciting ways get immediately rewarded, and there's all this hiring in this field, and then it kind of cools down because it becomes a common rote exercise that's not rewarded, and you need to have intelligence and knowledge and new perspectives to use it. And so pushing back on Lisa's point, I don't understand why you believe that AI will turn into a narrowing of the field. It feels like you're talking about we need these cultural frameworks I think already exist, right? We're gonna, we already talked about, these garbage papers are not going, AI papers aren't going to be accepted by these journals, that there might be a real, if you can use this tool effectively to make exciting research, that's fantastic. And it seems like it's not clear that AI lab will be the one that that does get the funding rewards, that does get the scientific rewards, that gets any of the glory if any idiot can tell ChatGPT to make my lab for me. So I wonder about why you're pessimistic in that way instead of thinking that why you think our structures aren't robust. Maybe there'll be a few nicks and scrapes, but then we'll figure it out.
Great question. As you've seen different paradigms shift in your field, have you ever seen universities put out calls to hire 100 people in the area that you're,
A cluster that hired like 6 people in genomics,
Okay, yeah, that's the scale. Okay, but that's a real significant scalar issue, and we are just dealing with a industry that has staked its future on this technology, and the university is a very fertile place to get some of these returns. So in many ways I agree with you that I don't actually see the promise of these tools in any significant and field-changing way. And so I do agree with you that there'll be this petering out. I just think that the moment between where we are now and what happens when we peter, the question is, what will we lose in that course? And I think we risk losing a lot more than in these previous paradigm shifts because of the enormous investment and the enormous top-down insistence from my university, at least, that every single unit look deep within their soul and ask, do you have an AI use, right? So, that's a difference.
But I think that I don't see this as an issue. You hire 100 faculty, they all have in common some level of usage/understanding of AI. But when you hire a faculty, you hire a professor, a researcher that has a long-term view. You're hiring a person that that you think you can evaluate is a person that's going to be able to react to the change of the field. As an example, in my field, when I started, there was the Hubble Space Telescope. Now we have the James Webb Space Telescope. We have 10-meter telescope on the ground. We're going to have 30-meter telescope. There's going to be many changes. It's not that I am not able to do research anymore because the tool that I was using when I was hired is not cool anymore. So I'm not too worried about that. If we hire good people, they won't use AI anymore. They will use something else. They will adapt, and we will be fine.
I think really a lot of the critical attention that we're all having is really about large language models. One of the things I tried to do in my book is I talk about 30 to 40 other deep learning architectures in cognitive science, I feel like a kid in a candy store these days because there's so many things you can do by putting together different components of different models to get really cool effects if you're treating them as cognitive models of different phenomena. It's the large language models that are really being pushed on everyone all over the place. And the ideal future, and I think this is really a, maybe a 50-50 possibility, is that people just get bored with them, right? Because the outputs, they all look kind of generic. After you've looked at 10 or 20 of them for some particular thing, you start to get some sense of ability to recognize them, even if it's not accurate enough to really throw the book at somebody for plagiarism just on your intuitions. You just get bored with them, right? And that would be like the ideal future for me, is that this just kind of peters out, the large language model mania, at least specifically, and then we can focus more on things like, AlphaFold and things like the really interesting cognitive modeling that's a little bit more niche, a little bit more theoretically motivated, where you have all those structural links between the system you're trying to understand and the model.
So here in the front, yep.
Thank you. I'd like to direct this question at Professor Buckner because I think his remarks most closely reflect the spirit of the question. Does AI inherently foster an instrumentalist view of science in contrast to a more realistic view? By instrumentalist, I mean a view that predictive accuracy is all that matters in science. By realistic view, I mean a view that science helps us understand the nature of the real world in terms of explanatory theories and models. So, is AI purely an instrumentalist tool, or can it help us understand the nature of reality?
Yeah, who are you, a philosopher?
Yes.
I mean, so this is a question that I would treat as like a central organizing thread for a whole graduate seminar in realism versus anti-realism, right? I have a kind of Quinean pragmatic realist view. This might not be useful to most of the rest of the audience, but I'll just try to give you a vibe of my answer, right? Which is that when you try to be a pragmatist about what amount the realism, anti-realism distinction amounts to, you end up with the idea that, well, there are kind of shallow instrumentalist goals, and then there's sort of really deep, unifying, cross-theoretical, metaphysically informed realist goals. And it's not that they're not about your ability to not do things differently in the world in some kind of like Kantian versus non-Kantian way. But the idea is that being a really thorough, holistic, philosophically informed instrumentalist just kind of collapses into being a certain type of realist. So I'm kind of in this very intermediate state where like Richard Boyd and Quine would tend to occupy, as opposed to like a really hardcore, the world is the way it is, independent of any of our interests in it, or versus a really hardcore anti-realist view, that there just is no fact of the matter of anything. It's all just our arbitrary purposes. This is more like showing my identity card and where I am on the realism, anti-realism debate.
No, I appreciate that. That's where you are, your position, a valid position. But
Yeah.
the question is, does AI
Yeah. So I think the simplistic way of using AI definitely does push you towards a more kind of very thin type of instrumentalism, and I think we need to avoid that. But the way you would do it is by emphasizing things like the difference between knowing a cause versus a correlation, right? And that really is a difference between your ability to do things in the world versus not do things in the world, right? So like if you had an AI model that was just gobbling up a whole bunch of data and it was making a whole bunch of predictions on the basis of the correlations in that data set, it might tell you that if you pinch the rooster, you could make the sun rise, right? But that's not something you can actually do in the world. So having a systematic view where you try to integrate whatever the AI is telling you with what you know about the causal organization of the world is going to be the way to really get an understanding that's not going to lead you to make those kind of thinly instrumentalist takes. But this is, I mean, just to tie it back to the stuff that we've already talked about, like with Centaur, for example, I think this is a great example, right? So if you thought all there was to having a good theory of human cognition was the ability to have a really, really high fit to the widest data set of experimental data that you'd gathered before, you wouldn't worry so much about this process and underlying causal structure stuff that I've been emphasizing, right? But I think you don't even know that you have a good phenomenological model if you don't have any of that. And some people have already shown this with Centaur specifically. So one of the critical examinations of Centaur says, well, what if we put people under different short-term memory loads while they're doing the task? Does it still generalize as making good predictions about other people's behavior in experiments? And it failed, right? So even though it's the best phenomenological model we've ever had for this vast, vast swath of behavioral data, it fails on this really trivial kind of architectural intervention, where if you had a causal model, right, where you could draw links between the underlying cognitive organization of the human subject and the trial and whatever Centaur's doing, you know, you might build like a little short-term memory module or something, and you could say that's the relevant intervention that we should be making to get the right instrumentally useful prediction in this experiment, but it doesn't have that. So the kinds of predictions it can give you are thin and brittle and so on as a result of being too predictively instrumentalist.
Okay, I know we have some more questions, but I also want to be careful about our time. And the panelists are going to be available in the break if people had a particular question they would like to ask them. Also wanted to remind you that the coffee break is half an hour, and starting on the hour at 4 p.m. will be the keynote address from Carl Bergstrom. So hopefully you can stay with us for that as well. But will you please join with me in thanking the panel for the conversation?